Explain this graph now. The graph is very important. From this graph there are a lot of conclusions which can be drawn. Okay. So if you consider vapor pressure in the y-axis, this is also representing vapor pressure. And we'll mark that there are two components. Component A, let this be the partial vapor pressure of pure component A. So what is this? This is partial pressure of pure component A, this particular point. Okay. Similarly, this particular point is representing P naught B, so it is representing partial vapor pressure of pure component B. Okay. In the x-axis, you will have mole fraction. So, since this axis is discussing about component A, and this particular y-axis is discussing component B, we can say that this would be pure component A. This particular line represents pure vapor pressure of this particular starting represents mole fraction of component A only. So this is mole fraction of component A only. Similarly, this particular point represent mole fraction of component B only. But you are having other than these 2 points, you are having the entire graph like this. So what does this thick black line represents other than these 2 points? These represents very clearly that these are mole fraction of the both the components. So other than the origin, so I can say that here, I can write a note here for you. Other than the two origin points, that is other than these 2 points, okay, mole fraction is a mixture of both components. Okay. So therefore I can say here at this point xb is equal to 0, at this point xa is equal to 0, because there are pure components. If it is unity, then definitely the other should be 0. Okay. Now we try to connect these graphs and see what we can get from these graphs. This is one plot, okay, and this is your another plot. Okay, next you can also as well connect these two plots here also. What does this line represent? This line represents total pressure, which is the sum of partial pressures of both the components. What does this line represent over here? What does this represent? This represents partial pressure of B. What does this represent? This represents partial pressure of A. So therefore PB is equal to P naught B into XB. So this entire line represents like this. This line represents PA equal to P naught A into XA. But at any point of time, this PT will represent the sum of the partial pressures of the components. P naught A XA plus P naught B XB. Right, so this entire graph, this graph will represent you the PT is equal to P naught PA plus PB. So from these graphs you can take a lot of conclusions. Total vapor pressure over the solution can be related to mole fraction of any one of the components. Instead of XA you can substitute for XB, or instead of XB you can substitute XA. Depending on the vapor pressures of pure components A and B, total pressure over the solution decreases or increases with increase in the mole fraction of components, either of the components. In the next calculation, we are going to also see the composition of vapor phase.